Hello, everybody, and welcome to this workshop. I'm really very pleased to meet you all online, but well, it's a pity that we are not all together next to the Adriatic Sea. So, because I know some of you have just arrived there, I hope everything is
Aegean,
okay.
Aegean Sea, Aegean
The
Sea.
Aegean Sea, not the Adriatic. Oh, okay, my geographic is is awful. So, well, we are here to show you the ongoing works of one of our best well-known projects inside the or within the GlossaLAB ecosystem, which we call comLAB. We use comLAB to clarify our students what I think is not moving the presentation. It's,
That's the last one. That's the last one. You are starting.
no, but it's not moving, not in any direction. Let me put okay. Put again. Okay, it's here. What is happening with everything today?
Now.
Now, okay. So we use this project to improve, like the title is showing you, to help the students improve their understanding about the telecommunication system. So I'm not going to show you how a telecommunication system works, but we are going to try to show you how we are using our GlossaLAB, glossary, and all this ecosystem we are developing to improve the understanding and the transmission of knowledge and information. So, well, the first part is we are working with this scheme where you can see this is a complete chain of communication we use in telecommunication area to check every part of the communication process. So we start in the upper part on the left corner of the chain, and we start with people who want to communicate something, maybe talking and spreading the information along a radio, for example, a radio channel. So we are going to use this system to show the students how any part of the communication chain works. So what the way of working with these models is to go through all these boxes, following the lines, and in the arrow direction, and checking which is happening in each of these parts. So, well, the classic way of doing this is to use a programming language or any kind of system to simulate whatever is happening with firstly with the information, how we are going to code it, to transform it, to make something that could go and travel through all the channels and the systems. You can imagine antennas, receivers, anything that we use to make a telecommunication system. And we need to show the students how any part works. So they usually click on these parts, make like a zoom, and show whatever is happening with the mathematicals, with the mathematics, and with the algorithms that are programmed inside any of these boxes. So tell me.
Isaac, Isaac, if you click on it, there was an anime. If you click,
Yeah,
the,
I was only talking and not using the mouse. So well, you were right. Okay. So well, when we use this system, we want to also not only show the effects of the simulation, but we want the students to profundize in the acquisition of knowledge about any of these parts. So we are going to introduce our students in what firstly we are going to give them the code and all the elements that they need to run the simulations, but we want them to give them more information that not only the language programming and the mathematical thing. So I prefer to show you, if I could, within the real platform. I'm going to share our GlossaLAB page. Let me share it. So what? Instead of going through the PowerPoint slides, here is what we have developed inside this comLAB project. We have we are using this glossary page to give them the starting point with all the information they need. So clicking in these links, I'm sorry, it's in Spanish. It's not. I don't know, Daniel, if we have the translation. How is the translation in progress? But for now, I show you the real one that we are using during this semester in our courses. So clicking in these links, we are going to get the students travel through all the knowledge and through all the learning processes. They have all the information they need to not only run the simulation, but also profundize in the theoretical parts of these models. So, for example, we can show these pages. All the pages are built in the same way. We have all the information that they need to read to acquire whatever they need to learn about the terms or the concepts they are studying. And also they are going to also receive the links that they need to put this code or this programming code in production. To run the simulation of any part, and also to change whatever they need to make corrections or new simulation or new add-ons to all the parts of these models. So what we want to achieve with this, going back to the presentation. What we want to achieve with this ecosystem is to make the students work in three kinds of contexts. We have the traditional context for the engineering students with programming language, all the programs they need to run the simulation. They have this working directory where they can share the codes directly with us. We are providing our codes using these shared directories, and also they are going to share with us what they are working on. And also they have this auxiliary representation to profundize in the knowledge of what the mathematical formulas are making with the signals, with the voice, or with all the information they are working with. Another context is this simulation chain we have shown you before, where they can click on any of these parts of the chain to also have a visualization element that is going to show the students whatever is happening in real time. So the first context is not real time. They have to make change to check what they are doing, but it's not a working or simulation that they can check in real time. But in this second context, they can run the simulation and listen in the voice and whatever is receiving the receptor, and in real time check what the model is doing with the information. And the third one, but not the less important, is this clarification part, where we are using these textual pages with the information to clarify also the whatever is doing in a conceptual way. So they are going to follow the learning process in this way of encapsulation of the complexity, but because they are trying to learn very complex concept that they cannot learn alone by only reading the explanation of this concept, of the mathematical of this concept. They need some practical or some simulations, a practical way to encapsulate or to follow whatever is happening in the process. So this way of working can also make different layers to encapsulate the complexity of the problem, because we can only need to show whatever is happening maybe in blocks that are near to us in a very high level, or maybe we want to know what is happening in the most deeper part of the chain. So we can use this way of zooming or getting deep into these blocks by clicking on them to get to the last one, to the last mathematical operation, for the minimal maybe sum or product we have program to check it, to correct it, or only to know how it's working. So, well, following this slide, you can check what is inside these blocks in the upper layer, and all these other blocks are working inside one of them. So if you need to go to the deep part of the simulation, you can go following this block, clicking and zooming and getting go and down. Well, so this is why we have call it from the back and the forth, because we can get a connection with the theory, from the theory to the practice, using our GlossaLAB glossary, like the linking part of the ecosystem, because we can click on one of these boxes to go inside it and check what you are seeing in this slide with these mathematical parameters, with all the explanation, what you have to configure to run correctly the simulation. But if you don't know whatever it means, all these numbers and telecommunication abstract things, you can go with this help button to a fully explained web page, where we are going to clarify all the terms and concepts that are working together in this simulation. So you can go again back to the most high level part or to the more simple part, or whatever you need to go to improve your learning and your understanding of the situation. Okay, so this for example is an example of one of the most important part in this telecommunication chain, that is the optimal receiver, and you can check in this example that we have developed this clarification page in a way that trying to follow this need of clear language that we are developing in our new project in CleanFo, because we always are always having this first part of the text where we are going to introduce the reader to the concept, with some introduction, historical relation, the author. Well, this a most liked part of the information that you need to know what a optimal receiver is, and we are following in the explanation of the a mathematical theory of this this concept, and finishing in what you need to program to get this this receiver in our simulation chain. So you can go through this page to get to the last part of the code that you need to run into the Simulink or MATLAB system. Well, so well, this is what we want to show you today, because this is what we have developed. I want to give credit to my colleagues Jose Maria Diaz and Daniel Gracia, because they are working mostly than me in this project, and this is what we have to give this. We want to include this project in all of this ecosystem that we are developing to improve the clarification of the information and to improve the learning of our students. So for today, I don't have nothing more to tell you. Thank you for your attention, and if you want to make any question, we are the three connected to these workshops, so we can answer any curiosity or any question that you could have.
Thank you. Thank you very much, Isaac.